Alright, so now we need to talk about the third type of permutation, solving counting problems using permutations of n non-distinct objects. We'll now examine the third type of permutation, which was the non-distinct case. N objects not distinct, and all the objects are used in the arrangement. And we're going to illustrate how this is going to work with the next two examples from our workbook. So we're going to turn to page 138 of our workbook and look at problem number 8. So how many four-letter words can you form from the word math? So you're looking at math, and I've got 4, and I'm using all 4. And it's kind of misleading when they use the words here, because they're just saying how many different 4-character things can you form from this. So like ATHM is not literally a word, but they're counting that as a word in this example, if that makes any sense. So we're going to do, we have 4 objects. We're picking 4 at a time. They're all distinct. That gives us 24. So we have 24, and I'm going to put this in quotation, words can be formed. Now, how many 4-letter words can you form the word lull? Now here we've got repetition. So let's think about this. I could do U-L-L-L. I could do L-U-L-L. I could do L-L-U-L. And I could do L-L-L-U. So there's only 4 words we can form here. Now, if these are all distinct, there was 24, but here the problem is that we have this being repeated. We've got L, that there's 3 L's here. Now think about having 3 L's. Ask yourself, what's 3 factorial? That's 6. 24 divided by 6 gives us 4. So let's see how that works. So the number of ways that L can be arranged in a particular permutation is 6, which equals 3 factorial ways. I could do L1, 2, 3, L1, 3, 2, L2, 1, 3, L2, 3, 1, L3, 1, 2, and L3, 2, 1. And so notice that 4 equals 24 divided by 6, which is the number of ways to form a 4-letter word, divided by the number of ways the letter L can be arranged. And this illustrates the next theorem. Permutations of n non-distinct objects. The number of permutations of n objects where p items are identical and q items are identical, r items are identical, and so forth is n factorial, all divided by p factorial times q factorial times r factorial, so on and so forth. So let's go back to our workbook and take a look at problem number 10. So we're going to look at how many 7-letter words can you form from the word success. And by the way, as you're working on these, on your formula sheet, if you turn to the back side, you've got these formulas here. It's like here we're doing the duplicate items permutations. So this is what I want to use here. So my top number is going to be 7 factorial. Now let's see what repeats. We have 1, 2, 3 S's. So that's 3 factorial. And we've got 2 c's, 2 factorial. So I want to go ahead and plug that into our calculator. And then just hit enter. So it'd be 420 words.